Okay, so we're going to prove that if BY and CZ are angle bisectors of isosceles triangle ABC with base BC, then BY is congruent to CZ. So let's go ahead and start the proof. So we know that a triangle ABC is isosceles, right? With base BC. This implies that AB is congruent to AC. And if we have AB is congruent to AC, this implies by the isosceles triangle theorem that angle B is congruent to angle C, right? The other bit of information we know is that BY is an angle bisector. So we have BY is an angle bisector, implies that angle ABY is congruent to angle YBC. Right? We know that this angle is congruent to this angle here, right? So we also know that CZ is an angle bisector. So CZ is an angle bisector, implies that ACZ, angle ACZ, is congruent to angle ZCB. Right? We know that this angle is congruent to this angle. And notice I use one tally for each of these because it's easily proven that if angle B is congruent to angle C, and this angle is congruent to this angle, and this angle is congruent to that angle, then all four of these angles are congruent to each other. But we're just going to want to prove in particular that this angle, so let me erase the ones that we're not going to be concerned with. I just want to show that this angle here is congruent to this angle here. So we're going to consider triangle ABY and ACZ, because if we can show that those two triangles are congruent, then we know that BY is congruent to CZ because those are the corresponding sides. And we do have it, right? We have angle A is congruent to angle A in both of those triangles, right? We have AB is congruent to AC, and we have ABY is congruent to ACZ. So angle, side, angle, angle, side, angle. Now we just have to consider these two triangles and show that ABY is in fact congruent to ACZ. So let's go ahead and do that right now. Consider triangle ABY and triangle ACZ. Well, we know that the measure of angle B is equal to the measure of angle C. So this implies, so the measure of angle B, right, is the measure of angle ABY plus the measure of angle YBC. And we know that CZ, right? Angle C is ACZ plus ZCB, right? ACZ plus ZCB, right? So this is the measure of angle ACZ plus the measure of angle ZCB, right? So we know since B is equal to C, those angles are equal. That means these sums are equal. And we know that ABY is congruent to YBC. So instead of writing YBC, we'll want to write, YBC, we'll want to just write 2ABY, right? So this implies that the measure of angle ABY plus the measure of angle ABY is equal to the measure of angle ACZ plus the measure of angle AZC. And of course, this implies that the 2, right? 2 measure angle ABY is equal to 2 measure of angle ACZ. Then you can divide both sides by 2 to get the measure of angle ABY is in fact equal to the measure of angle ACZ, which of course means that angle ABY is congruent to angle ACZ. So, like I said, we were able to show that this angle is in fact congruent to this angle. So we have angle, side, angle. So let's go ahead and just write that. So we have that angle A is congruent to angle A. We have that AB, side AB, is congruent to side AC. And we have that angle ABY is congruent to angle ACZ. These three things together, implied by angle, side, angle congruency postulate, that triangle ABY is congruent to triangle ACZ. And since this triangle here is congruent to this triangle here, that means these corresponding sides, BY is congruent to corresponding side CZ. So this implies that BY is congruent to CZ. And that is the proof.